let's think back to what we did just immediately previous to this, right? We introduced a few different ideas. In particular, we looked at when you're arranging things, we stepped away from probability for a little while, and just think about, I've got a bunch of things, and I want to arrange them, okay? When the order matters, we gave that a special name. We called them permutations. Very good. Okay, and then we noticed there are really two kinds of permutations, okay? Two kinds. And it's based on whether you replace what you're arranging or you don't replace, okay? So when you do replace, okay, and if you got n objects and you want to arrange k of them, right? N objects, k spots to put them into, okay? What's the number of arrangements with replacement? Does anyone remember? With replacement, right? So our example was the 4-digit pin, wasn't it? Okay, and you're like, I've got 10 options here, 10 options here, etc. So when you've got n different things to choose from, right? It's that times itself, however many number of spots you need to put it into. And that's why with our 4-digit pin, we said, look, you've got 10 different digits that you can put in there, and you have 4 spots to put them in. So 10 to the 4, 10,000 options, okay? Then we said, all right, now, if you don't replace, if rather than, say, numbers on a keypad, you're thinking about horses in a race, and one horse can't be first and second and third, so it's a scenario without replacement, right? Then we got into some factorials. Now, before we do the fancy notation that we introduced, right? What was it in factorial notation? How did we write it in terms of n's and k's? Started with n factorial. And then I have to divide by, what do I divide by? N minus k, good. Factorial. And we said, look, this is so important. It's such a big deal. It gets its own notation, namely npk. All right? So far so good. Now let's have a look at some interesting cases of this, right? I want to go after this without replacement situation because in real life it's far more common. When I'm arranging stuff, I usually have actual objects and I can't repeat them. Okay? So here we go. Special case. Okay? Let's look at an easy special case, one you're actually pretty familiar with. Okay? What if I've got n objects, right? And I just want to arrange all of them. Okay, so for example, I was talking about horse races before, right? First, second, third. Suppose I only have 3 horses, right? So everyone's going to get a place. Everyone wins, kind of, It's like I came third in a group of 3. Now, how many ways are there to arrange them? Well, let's think of it through this lens, okay? Think of it through this lens. The example we're looking at is 3 horses. So I've got 3 things to choose from, right? And I want to pick out or permute 3 of them. 3p3. Is that all right? So what does this become when we go to factorial notation? It's not that hard. You got 3 factorial on the top. What do you have on the denominator? 0. You've got 0 factorial. Now we talked about 0 factorial earlier in the year, didn't we? Right? Here is another reason why 0 factorial must be 1, because it wouldn't make sense if it was anything else, right? So there you go. It's 3 factorial, which of course is 6, right? So more generally speaking, we can say nPn is equal to n factorial, right? We actually know this. We've looked at this before. We just haven't couched it in these kinds of terms, right? I mean, more specifically, it's n factorial and 0 factorial, but that's always just n factorial, okay?